Hey there, folks. So last episode we did some cleanup and some minor refactoring for our find flea point for our AI. Let's wait for him to move. There you go. You can see he now actually runs. This episode I wanted to work on the reevaluate flea, because if you notice, we'll leave him just standing there, and you notice he's going to keep fleeing. And if I bring up our behavior tree that we created, come on. Thank you, content browser. You can see we're going into this flee state. Let's actually stop that and see if we can get this to debug live. Pull that over. We're going to play. So yeah, you can see we have currently they are going through the idle state. And let's run over there and try and trigger the flee. You going to turn around or are you going to walk off elsewhere? There you go. So we trigger the flee state. Apparently that was the best direction. But you can see they are stuck in the flee state. And that is because we are just doing this wait right here that isn't causing the NPC to reevaluate. So we're going to be working on that. So first of all, reevaluate reaction state. So what I want to do is I want to leave that wait in there, and then I want them to reevaluate. I'm going to take this wait down to, it's either going to be instant or 2 seconds. But so we have the reevaluate reaction state. And as you can see, we haven't added anything there. So it's just got that Blackboard based node name. And I do apologize if I sound a little off today. I am battling a cold. So hopefully it's not too bad in the audio for this episode. But either way, this is what we need to work on here. So I'm going to close out of this and the editor. I'd actually just launched the editor independently, so I'm not going to have any issues there. So with that, there is a couple of minor changes I want to make to some of the things I've done so far. The very first one is actually going to be this get value as vector for the target character. It's misleading. It also doesn't give us everything we need. So we're actually going to be changing that to an object, which means we do need to make some changes here into our find flea point. Apparently my fingers are on the wrong key. Get actor location. Believe that's the right one there. I'm going to leave that for now. We'll change that in a moment. The other thing we need to do with that, though, is in our controller base, we actually need to set that. So this, actually, I can just copy most of this here. Again, my fingers are off place. I wonder what's set value as object. I'm just going to alright, and apparently IntelliSense doesn't want to work yet. So I'm going to pause the video quickly, just let IntelliSense catch up, and I will be back momentarily. I say that, I look over to pause the recording, look back, and IntelliSense is working. So quickly fix that typo there. So we have set value as object. So I'm going to actually just comment out this line of code here, and now that IntelliSense working. Express myself. It's a pointer, that's why I believe. Get actor location. What do we have exposed? Not letting me cast, so those. Okay, so doesn't let us use that default cast. Anyway, so we've just gone through here and very basic. We've got the sorry, brain is not working with this cold. So we've gone through and we've just changed that over from being just a vector to an object. That's going to allow us to do some of the other work we need to do within this reaction state. But first and foremost, we need to set that up. So in our header here, we are going to copy over pretty much the exact same stuff we have done in our other ones. Find flee point. So you can see we have a flee distance and then the constructor and the execute task. So we are going to create our constructor and our execute task. Oh. Let's copy these because it's easier than typing it out by hand. Now with this, we don't actually need any variables that I am currently aware of to have, and that's things like we've got our flee distance that we've defined for the flee task, or we have our random point and radius, we have that search distance. So we don't need those for this, so I'm just going to now close out of these. We are going to create this definition, and it's probably not going to allow us to do this one, so create our constructor. Okay, so first of all, we're just going to give it its node name. Reevaluate reaction state. All right. So now with the execute task, we're going to need to get from the AI controller's perception component, we're going to need to get all actors. It's actually a function that's exposed through the perception component of get all actors, get currently perceived actors, sorry. And where you can find this, there's a couple of different places. We've got, obviously, the Unreal documentation. The other thing you can do is if you right-click on your declaration for the perception component and go to declaration. Now, this does take a moment because, or at least in my system, because IntelliSense is slow, but it should, ultimately open up the AI perception component header file, which you can also go to your include and just go to the document. It'll actually open that up pretty quick as well. So in here you have a ton of information exposed to you, and most people don't actually go about it this way. I found most people tend to go to the Unreal documentation, and don't get me wrong, this is useful, but a lot of it's pretty basic. So if we go in here and where's that function? Get where's it? Get currently perceived. So in here, just do a Control F, get currently. Well, it's not exposed. Okay, perceived. I obviously typed it wrong because it's right there. So here's that function. If sense to use is none, this is actually the exact information on the website. And the description information on the website is this little comment here. But what you can do is go to definition. Now, for anyone who doesn't understand C++ really well, this might not mean much to you, but you can go through here and, okay, what does this do? So we're saying the sense to use, we're taking in a parameter for the sense to use, and we're taking in an array of actors that we want to populate. So sense to use ID, if you don't pass one in, this is going to be null. Out actors reserve perception data, perceptual data.num. What this is doing is just saying, okay, this actor can see 12 actors. This NPC can see, or sense, I should say, not see, sense 12 other actors. We're going to say out actors cannot be any bigger than 12. We're going to predefine that number, and then it's going to iterate through all of those perceived actors, and it's going to say if it's perceived by the sense. If it is, we're going to push it into our out array. And that's what we want to use here, basically. And I understand this is a little different than my normal videos, but I wanted to try and explain how I go about doing things. So this is the function we're wanting. Now, with that, we need to pass in a sense, and we need to pass in the array we want populated. So back in our AI controller, what we are going to be doing here is a U function blueprint callable. Now, because we're passing in that array, we can't make this one a pure function, in my opinion. So it's going to be a T array of A actor pointers, get perceived actors. And I've spelled perceived wrong. Now, I will explain this as I go. So we're putting this on the AI controller because we don't want to expose our perception component. We want that to all be managed by the AI controller itself. So we need to create a function that is, well, it's not really a pass-through. So we're going to create this definition. I'm going to cut this. Oh, no. Sorry, my natural key selection is just off today because of my head cold. So TArray return ret. As I've done in previous other ones, we're going to return ret. And what we're going to do here is, because in this case I don't want any perception, individual perception stimuli, like I don't want to differentiate between can I hear them, can I see them. It's just if there's actors, let me know. So what we're going to do here is perception component get currently. Why are you get currently perceived actors? There we go. We're going to leave this as null pointer, and we're going to pass in ret. And this is a very simple pass-through function. It's the pass-through function itself is creating the T array, we're populating it, and then we're passing back that T array. So now that we've got that, we can go back to our actual behavior tree task. So, well, we've got a lot of the code we're going to be using already defined in our find flee point. Well, not all of the code, but some of the code. So I'm going to go in here and, well, right here, this is the first thing we're going to want. We want to go if the AI controller is our controller base or can be cast to our controller base. So I'm going to grab that. And it's going to throw, obviously, the include issue, which is very easy to fix. All right. So in there, now that we've got that, we can just go TRA of a actor pointers, perceived equals con.get perceived actors. And then what we're going to do for const auto. Now, we actually don't need, no, because we already know they're A actors. We don't need to do the auto. So we're going to iterate through all of those. And the reason being is we know specifically that the NPC was fleeing a particular AI, or a particular thing, I should say. So what we're going to want to do from there is grab this actually. Grab this code out. So A actor pointer fled actor. U actor Blackboard component. So, anyway, sorry, I'm skipping all over the place, and I do apologize. Hopefully, this head code's not lasting too long, because I understand this video is probably not going to be the best of quality, but I do want to try and continue working on the project, as I'm actually off work right now because of this head cold. So trying to record things as I go. I don't want to like skip things and have to go back and re-record. So, okay, so let's work through this back from the start. So we've got a list of all of the actors that are currently perceived. We have the actor we were fleeing from. And the other thing we're going to need here is a bool still flee. I'm going to set this to false. So what we're going to do here is for every actor we can perceive, we're going to say if, still flee equals to A is equal to fleed actor. If still flee, break. And this is just to save us reevaluating. So if we get an array of, let's say, 10 perceived actors, and the second actor in that array is the one we were fleeing from, we don't need to worry about the other 8 actors. We know we still need to flee, so that's what we're doing here. So basically we're saying is if this actor that was in the array returned is the one we ran away from, we're going to say still flee, and we're going to stop the continued evaluation. The next thing we need to do there then is actually set our... Is it in this one? Oh no, that's find flee point. That's in our AI controller. Sorry. We have this value here. So what we are going to do, I'm going to put this back to, so I'm just going to copy that and I'll put this back to. So this, get Blackboard component. No, that's owner comp. Not this. Owner comp that get Blackboard component, set value as int reaction value. Now we don't have anything defined there. So what we're going to do is still flee. And if it's true, well, what was our flee state? That was, oh, monkeys, I forgot. Data types. My brain is not working and it's been too long. Reaction type. Flee was 0. So we want to set it to 1 if it's not still flee, and 0 if it is. All right. Okay, now we've done that. It's just the normal finish off the reaction, the blueprint behavior tree task logic. So I'm just going to open up our find flee point, and that's this one here, the finish latent task with the succeed or fail. So I'm going to say finish latent task with a succeed and finish latent task with a fail. And for anyone who may be skipping through episodes or isn't 100% sure, the reason why you want to include these finish latent tasks with, and then the succeed or fail is it's used by our behavior tree logic to dictate and decide which of the execution branches it needs to run down. So anyways, I'm going to do a build here, and I will be back either in the editor when we're ready to give this a test, or if there's a build error, I'll be back once that's thrown. Alright, so we're back in the editor, and everything seemed to build fine. We'll open up our behavior tree here a second, just take a look, make sure our node name has gone through. Yeah, you can see reevaluate reaction state there. So what I did, once the build completed, I just threw a quick breakpoint here on the execute task, so we can make sure to walk through and see what's going on there. So, where is our AI now? Where do you run off to? Oh, he's right there. Okay, let's... Oh, we have a bad code. Oh, that's our... I know exactly what that is. So that is I failed to change the Blackboard data type. So we'll just launch back into the editor here. This hopefully won't take too long because it just built and launched. But yeah, so that is something you need to be aware of, especially when you're making changes to data types. And that's like here, we set it as an object instead of a vector. We didn't change it in the Blackboard. Minor things like that are going to, as you just see, cause exception, or just seen, caused an exception, and it caused the editor to bail. Because those are things, obviously, it's not intended to do. You're not meant to be setting a vector key as an object, things like that. So, and yeah, those, again, as I've mentioned, every time I do silly mistakes like this, those are things that come up every day as part of programming. It doesn't matter how good of a programmer you are, you're going to find little simple mistakes. So, open up our Blackboard here. You can open up. Yep, there we go. And you can see target character is still a vector. So we're going to select that. And we need to change this to a object. Save that. And we'll give this a try again and see if that fixes that crash we just got. And it's these sort of issues that you want to test your changes frequently as possible, because you're going to make, there we go, you can see he ran away. I forgot to reopen the behavior tree, but there we go, should hit our breakpoint. Okay, there we go. So let's take a look here. Perceived actors, we have one. And there's none, sorry, we have none in there. So this is why we set it to a default of false. So you can see it's false. Perceived actors is empty. So we're just going to straight through here, reaction to state, and we finish the task. So we hit continue. Now, obviously, they're still running. We didn't fix that. So let's drop out of this quickly, though, and I'll open up the behavior tree. And let's zoom this out a bit so we can actually see. You can't see the text, but that should be enough to see which path that's going down. Okay, so they're idling. We'll run through. It's going to hit that breakpoint. I'll just continue as soon as we hit it. Okay. Always running to that same point. I might have screwed something up there. I'm going to have to look into that. So we wait, we reevaluate, get rid of that breakpoint, hit continue. And you can see now they went back into their idle state. And then they're back into the flee state. So I may have an issue. I'm going to have to reevaluate that. But with that. But the other thing we're going to want to do here actually is, where did we set the on target detected? Where are we calling that? Get fair response, isn't it? No. Where are we calling that? I am drawing a blank. Find all references. Oh, find flee point. Okay, so we are doing it in there. We're all right. So all we have to do there is set sprinting still flee. And what this is going to do is, if they're still set to run, obviously we're just saying, okay, keep sprinting. But if they're not, then it will drop back out. The other thing I want to do here, though, is find flee point. There is obviously something off with the way this is being done. Vector flee point, because it's meant to just turn and run away. That's what this is for. Flee direction equals, look at rotation. Okay, so that is get the current AI's location. Flee point. No, it's still doing... Okay, now they're moving over to that corner constantly. Okay, let's try one more thing. I'm just going to move them out into the middle of the area. And we'll try this again just to see. So they're out there, they're walking. Okay, if this works, it should move towards the house. Nope, they are still getting... Okay, so let's change these values. I'm going to change that to 250 with a random radius of 50. Now, a lot of this is probably down to the fact I'm running in a pretty small area for comparison to what I'm thinking of here. I'm thinking of like out in the wild, you run into a deer in the forest. So I'm trying to approach that we can keep the desired direction in a particular way. So towards the house this time? Nope, they are still running to over there. Okay, so there is obviously some flaw in my look at rotation, because here, yeah, you can see the find flee point failed and it ultimately ended up back down there. So there is clearly, I will openly admit, I screwed something up here. There is clearly, I'm going to leave them in the middle there. There is something wrong in this logic here. So what I'm going to do between episodes is I'm going to sit there and I'm going to figure out just what I've messed up. And next episode will be fixing this, because obviously there is something wrong here. So with that though, folks, as always, thank you for watching. If there's any comments, questions, concerns, suggestions, please feel free to leave them in the comments below or hop on the Discord. Thanks again, and I will see you in the next episode.